Hello, my dear students. So, today we are going to discuss a very important question. In this question, 99% students make a mistake, right? So, topic is heat transfer, subtopic is conduction, right? So, the question is going to look very simple, but it's extremely tricky. And the best part, once you make the mistake, you never forget the concept again. So now it's your turn. Let's discuss the question of the day. Okay. So that is a rod having inner radius r, outer radius 2r. From inside it is hollow. Now conductivity of the material between surfaces is given by k is equal to 3r, where r is distance from their common axis. Means like this. So at any distance r. So we can say we have two cylindrical shells and inside some material is there. That material is having thermal conductivity k is equal to 3r, right? And we need to find thermal resistance of the rod. Obviously about what two surfaces? About these surfaces. So because this surface is maintained at temperature 2T, right surface is maintained at another temperature T. So between these 2 points, we need to find thermal resistance. So even these temperatures are not given, still we should be able to find thermal resistance. Suppose these temperatures are not given. So let's say it's just T1 or T2. Say that is not given. 2T or T, that is not given, no problem. So still we can find thermal resistance between surface 1 and surface 2. Okay. So students, try this for at least 2 minutes and then we discuss the detailed solution, right? Very important question. Okay. So the most important thing in this question is that how we can choose the elemental portion, right? So that is the crux point of the question. So proper selection of elemental part to write heat transfer equation. So that is the thing, right? So what element we should take? So we know that is I am going to solve this by two methods. So method number 1 is, so for any small part we can write resistance like this, L upon K, right? So what kind of element I should choose? I should choose an element so that thermal conductivity is same at each and every point of that element, right? So it means we should take a cylindrical shell like this. So like this cylindrical shell we should take, thickness dr. So here at distance r, everywhere conductivity is the same, right? So this resistance I can write L upon K. So L upon K, so K is 3r and area of cross section is 2 pi r into dr. So all the elements are in what, beta? Parallel, right? So now for these two surfaces, temperature difference is same. If you are considering any this is cylindrical element like this, so temperature difference is same, so we can say all the elements are in parallel. So 1 by r equivalent will be integration of 1 by dr. So what generally students do mistake, they are writing dr and they are trying to integrate here only, right? But we can integrate if the things are in series, but here the elements are in parallel. So we should write 1 by r equivalent as integration of 1 by dr. Just like in parallel we write formula, 1 by r equivalent is 1 by r1 plus 1 by r2 and so on like that. So this thing only I am adding 1 by dr. So 1 by dr of each and every element I have to add. So by this, by solving, I am getting r equivalent as L upon 14 pi r cube. So same question we can solve by another method. So one more method is there. So method 2 will be, I can first find the total heat transfer. By taking any element I can find heat transfer, and then R equivalent of any element should be temperature difference upon heat transfer, right? So that is method 2. So dq heat, like from same cylindrical element I can write law of heat conduction dq, right? So Ka delta T by L, delta T here is T, or we can write T1 minus T2 also, no problem, right? And here in place of delta T I can write again T1 minus T2. So this T1 minus T2 will get cancelled out. Okay, so this Q I am getting Q as 14 pi TRQ by L. So R equivalent will be this temperature difference upon this Q, heat flow rate. So what I am getting? Same answer, L upon 14 pi TRQ. Okay, so dear students, if you have done mistake in this question, then see what is your mistake, right, and correct it, right? And still you are not able to understand the concept, please message me in the comment section, right? Okay, thank you.